Okay, Assalamualaikum warahmatullahi wabarakatuh. Welcome to our session. We are going to talk about deep learning, which is specifically about image classification. This video is for major assignment in deep learning course of Universitas Mercubuana. Let me introduce my friends. We have Rosan. Say hi, Rosan.
Hi friends, I'm Rosan.
And we have Robbie. Say hi, Robbie.
Hello, hello, hello.
Okay, thank you. And so let me introduce myself. My name is Rizal Sufyan Rahman. So let's just go ahead. Um, okay. The technologies that we are going to use is using TensorFlow uh, and Keras, and of course Google Colab to provide us uh, in coding environment in Python. And then the dataset that we are going to use is fashion and men's clothing. You can check the details in the link that I have provided in description. So without further ado, let's show our code. First, Razan will show the code and he will explain how our code works. And Razan, you can share your screen.
So guys, did you see the code? So in here, like you can see, we have first is importing the dependency here. Like Rixa said before, the technologies we use here is the TensorFlow. So TensorFlow is one of the app. I mean the model or the premier open source for the deep learning framework to develop and maintain by Google. And around here, like you can see, we use the TensorFlow dataset and matplotlib py, pyplot, yes. And don't forget about the NumPy and pandas too. And after that, for the next step, we of course we have to importing the data. So the first is we use the one of the API from Keras is around here. So we put the dataset we got from the GitHub before the fashion MNIST and input it to the Keras becoming the dataset, and after that we train the image labels into the dataset because we want to get the array after that. And next step is we build the array because we want to know and count the dataset we had using the unique counts by NumPy, and voila, we get here the graph is balanced. It's around 6,000 or something. Yes. So for the checking data is Rixa. So Rixa, did you hear me?
Okay, Rosan, thank you very much. And so, guys, basically what Rosan have shown just a pie chart, which is the training data, which consists of around six 6,000 data in each category, right? And Okay, after this, we are going to check the data and pre-process data, which uh, shape our data into model. And Robbie will explain about that. So, Robbie, can you present yourself?
Okay, thank you, Riksa, for the switch. Okay, from here I will explain the next process. The next step is we check the data from the data set as as we have explained before or has been explained by Hanif. Uh, in the in here in importing the data, we divide the variable into the data set into four variable, that is train image, train labels, test image, and test labels. Basically, in the code here, we check the train image, the shape of the train image data, and as we can see, we print the data of train image and we get the result of 60,000 data, and it should be true because in here in pie chart we get around 6,000 per categories or per label or per class, so it should be 60,000 records. And here is the information of the dimension or the width and the height of the image itself. And as you can see, the length of the train label also should be 60,000 because the image data is 60,000 and the train label should be same too. Because if it's not the same, it means the image is not labeled or unsupervised. The next is test image. The test image is 10,000, and of course the test labels is also 10,000. The next the next step is checking the sample of the labels. As you can see here, in the train labels for the first record or first data, we get label of 9, or we can see here 9 is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's ankle boot. The first data is ankle boot in here, and the same for test labels. The first data is to ankle boot, and the next step is checking the if there are any, like, not a number value in the train image and the train label, because then the data inside the record or array should be number. It becomes problem if if the data is not a number. That is we print the number of non values, not a number values, in train labels, train image, test labels, and test image. And as you can see from the output here, sorry, the number of non values in uh, for variables is zero. That means we have like normal data here. The next step is showing the sample of 25 record in train image with train labels using the pipeline library. Here we show the 25 25 record. As you can see, here we arrange the plot to be 5 by 5. And as you can see, I said before that the first label is ankle boot. then this is the ankle boot, right? So this is the sample of the data from train image. We have like ankle boot, t-shirt top, dress, and so on and so on. And the next step, after we check the data, if there are any anomalies or like redundant data or so on, and we succeed from the checking the data, then the next step is to pre-process the data. The pre-process is needed because um, before we train the data should be normal or in the correct format. In here, uh, we try to inspect the first image, which is the ankle boot from before. And here, the value in the first record or the ankle boot is actually around 0 to 255. This is because it is the range of like um, color value. However, in neural network, the value should be scaled between 0 to 1 only. And because of that, we scale the value to 0, 0 to 1 using this code. Train image divided by 255 and test image is the same. And is uh, the next step is we inspect the image again, and as you can see, the value here is actually differ from the first. In here, we see the value is from 0 to 55, and here we see the value from 0 to 1. That means the format is already fixed, or the format is like suitable for the training. And the next is the training. We train the model. The first step is to setting up the layer. Here we use three layers in the network or the model. The first layer in the network, it actually transforms the image format from two-dimensional array into one-dimensional array. Uh, if you can imagine, from before we have like this to this. That's why the function here is flattened from two-dimensional array into one-dimensional array. And the next layer is we use dense layer with 128 nodes. So from uh, 28 by 28, it means 784 nodes. We transform it into 128 nodes by this layer. And the next layer is also dense layer with 10 nodes, only 10 nodes, because we have like 10 label or 10 categories of clothing in here. See, this is 10 categories of clothing. So the final or the output layer should be 10 nodes. Which nodes activate, then it is the prediction for the data. The next step is compile the model, or actually it's not compiling the model. It's much like um, setting up the or defining the optimizer, loss function, and metrics that will be used in the model. Here we use optimizer Adam, and loss function we use cross entropy, and the metrics is accuracy. After that, it's time for training the model. Here we use epoch 10. Actually, we can use like more than this value, for example 20 or 30 to increase the accuracy, but for this project which we only use 10. And as you can see, from epoch 1 into epoch 10, we get the accuracy. We get the final accuracy from the epoch is 95% accuracy. And the next step is evaluating the model. Here, we get the loss and the accuracy by the general or average value of the accuracy. And here we get around 88% accuracy. And the next session will be explained by Rixa.
Okay, thank you, Robbie, for explaining so detailed in pre-processing data. And basically, we got a high number of accuracy, which is 88%. In deep learning, I think it's so really high. Okay, let me explain about how we verify the model. Let me share my screen. Oh, okay. Let me jump in and can you read this, guys?
Yes.
Okay, thank you.
Yes, yes.
And where's the thing? Alright, this one. So when it comes to verifying the prediction, as we know that we got 88% accuracy, as Robbie explained, and this part is verifying to get the idea whether the model is really work. Using one or more image from test images variable, and the model will determine what type of image is this. And here is the function for basically for just creating image. Uh, from this code, as you can see, if the predicted label is correct or true, it's gonna be blue, and otherwise it's gonna be red. And this is just for the label, and this is for, well, actually we have to this picture, right? And I made this two function. The plot image is just for the left one, and the plot value array is for the right one. And the plot value array is, as you can see, it shows the plot bar of the prediction. And if the predicted label, I mean, if the predicted data is correct, it's gonna be blue, and if it's not correct, it's gonna be red. As you can see, there is a layer here. This is a softmax layer. I use softmax layer, which is typically the final output layer in neural network that perform multi-class classification. And this is the function for predict the test images variable. And in this part, I use index at 100 to get this data. And this is the uh, variable to to show the image, and this is the figure size and so forth. And here we can still calling the variable that I have stated before in above here. And this is plot image on the left side and plot value array on the right side. As we can see, in index 100, it shows that the data is dressed like this one, and the confidence level is 99%. And this is true. And below, you can see there are a lot of data that it shows here. In this code, I made the rows and calls uh, like 5 and calls is 3, and basically it's just looping for every uh, part. Image from below. And as you can see, I use for looping and the range of num images, and it's the same. I use plot image and plot value array, and the result is like this. As you can see, there are a lot of most of them are correct, and the color is blue. And also, we found that it has only one data that is basically wrong. It's um, it should be sneaker, but instead this model predict this is sandal. And as we can see, the confidence level is 85%, and this is the biggest, and the rest are just a little bit of this. So I think that's for my session. Uh, Rajan, can you help me close this session?
Okay, thank you, Riksa. So for the last session, we have, I have summarized this presentation. So from this presentation, we have done here is basically just show accuracy of this model is 88%, and we have verified the prediction, and most of the results are blue, which means correct, and only few of them are red, which mean incorrect. And I'd like to say this is the end of the session. If you have any opinion or disagree with we have said, just leave them on the comment below. And if you like this video, please give a thumbs up, and don't forget to ring the bell. And thank you
It's
for
something like
the our presentation tonight. Thank you and see ya.